Here we have one of our Garratt locos. This is number 143. Came from South Africa back in the 1990s. Came with 138, and it's done many miles on the Welsh Highland Railway ever since. So what makes a Garratt different and suitable for the Welsh Highland? Well, first of all, they're big, heavy locos. They weigh about 60 tonnes in working order. They're the most powerful 2-foot gauge steam loco ever built. I think that's correct. So they're very suitable for the heavy Welsh Highland trains that we have. They'll pull 10 carriages fairly easily. .143 is in steam today because the boiler inspector's coming. It's had its annual cold boiler exam, and today is the steam test day. And assuming the boiler inspector's happy, then it'll go into service on Saturday on the Santa train from Carnarvon. So if we have a look over here, we start at the front. This is a water tank sat on the engine unit. The engine unit can pivot under the boiler cradle. So this is the boiler cradle. It carries the boiler, and the pivot is in line here. Obviously in the centre, just under there. It's pretty inaccessible, but I'll show you that later. So the engine units under a Garratt are identical. So you could take a back unit out and put it under the front, or a front unit and put it under the back. So that makes life easier, that you don't have different parts end to end. The difference, of course, is that at the front you just have a water tank. At the back you have a water tank, got a coal bunker on top of it. So right about here, going back up there, the bottom bits got water in, the top bits got the coal in. So these locos, when they first came to us, they only had coal in the back, and they towed a separate water tank. So we've modified our locos to have coal and water in the back unit. So the reason for only having coal in the back unit was that the locos were built for Southwest Africa, for the Sumeb Corporation. So that was a mining corporation that ran long distances over the line there, that carried the ore to the port. But in fact, the locos never went to Southwest Africa because they'd, in the meantime, decided to change their oil to meter gauge. So these locos came to South African railways, and that's so we bought them from South Africa in the 90s. Yeah, so this is a fairly conventional boiler compared to a double fairley locomotive, which has obviously a double-ended boiler. But this is a relatively normal boiler. The advantage of the Garratt is that it can have quite a wide firebox and quite a deep firebox, because there's no wheels or rods underneath it or going past it. So the firebox is here and the ash pans are here. So there's plenty of room to get at the ash pans. and there's plenty of room for a wide firebox, so it means the boiler can be relatively big. It's got a lot of superheat, so it performs very well, but it's a conventional form of barrel firebox, single firebox. One of the kind of disadvantages of an articulated loco is that you obviously have to have ball joints or flexible hoses to carry the steam from the boiler cradle to the engine unit. So on a Garratt, this pipe here, this is the main steam pipe that takes steam to the front unit. It goes down there and then forward, and it comes to a ball joint on the line of the pivot. So the ball joint has to be on the line of the pivot, so that where the engine bends is where the ball joint is. So it goes through the ball joint and into the cylinders. Then the exhaust does a similar route, but lower down than the live steam pipe. It comes back to the ball, through a ball joint, underneath the live steam ball joint, and then back in a pipe, up in a pipe that joins the exhaust from the rear unit. So this pipe here is coming from the other side. That's another live steam pipe. It comes down here, through there, out, along here, in there, back under the cab floor, to a pivot, to a ball joint, again right over the pivot, and then the same arrangement into the cylinders of the back unit. Then the exhaust comes out again on a lower line to a ball joint here in the middle there. Water pipe from the front unit. There's a flexible hose that goes to the bottom of the tank, and then the water comes down here into a filter box. It's connected also to the back engine, the back unit's water tank, and then the water comes down these two copper pipes, one into this injector, and then the other copper pipe takes it across to the other side to the other injector. So all that piping, whilst it might seem like there's a lot of piping, it's relatively accessible compared to a fairly, so it's relatively easy to work on. I mean, you know, it's a swings and roundabouts thing. This thing here, it's a vacuum brake cylinder. You can see the piston rod going down, and then it pulls an arm up which applies the brake gear. So there's another one of these on the other side of the loco. So one of them pulls the brakes on the back unit, and the one on the other side pulls the brakes on the front unit. So they're big vacuum cylinders, and it's a pretty good, reliable arrangement of braking. So it's unlike the FR engines, which generally have steam brakes on the locos. These have vacuum brakes, so you've got to turn the ejector on even when you're running the light engine with these. But we do relatively little light engine mileage, so that's not really a disadvantage. So our other Garratt 87, that's an earlier Garratt than 138 and 143. That had a single vacuum cylinder operating the front end brakes, and it had a steam brake operating the back end. So it wasn't a very good arrangement. It didn't work as well as this arrangement. So in its last rebuild, we modified the boiler cradle of 87 to take two big vacuum cylinders. So we standardised it with this one and 138. As you can see, this one was built in Manchester 1958 by Bayer Peacock. So this was the last Bayer Peacock built Garratt in the world. There was a batch of Garratts built after this in 1968, but they were built by Hunslet Taylor. So Hunslet in the UK supplied the boilers, the frame plates, rods and some bits, and they were supplied to tailors in Johannesburg who assembled the engines, because by then Bayer Peacock had closed down, so they couldn't order any more from Bayer Peacock. But so we have the last Bayer Peacock built Garratt here, and we also have the first one, which is the K1 Garratt, which is at Boston Lodge at the moment. So that was a compound Garratt, and it was the, if you like, the prototype. It was built for Tasmania in the early 1900s. So it ran on the Welsh Highland for a few years, quite regularly, but it's nowhere near as powerful as these. So at the moment it gets used occasionally on galas and special trains and things. So we rely on these for the main hauling on the Welsh Highland at the moment. You would have thought that a Garratt would have a massive cab, but it's not that big, and this is the slightly enlarged version from the originals, which were built in the 1920s, where the back of the cab was on this line here, so even smaller. But anyway, they managed to make it a bit bigger for the later batches of Garratts. As I said, the boiler is fairly conventional. You've got 2 gauge glasses, sliding fire roll door, vacuum brake valve, but not with the ejector, because the ejector's outside, because they were obviously realised that having too many hot things in the cab in South Africa was not a good idea. Wood-lined roof to again, hopefully reduce the temperature, and a nice sunroof for those very hot days when it's not raining. The main manifold is outside the cab as well, with the valve spindles coming through, so you've got all your shut-off valves here, and you can see they're labelled up with what they do. And then you can see a conventional duplex vacuum gauge. And then this single vacuum gauge looks at the reservoir just on the locomotive. So, and on the brake valve, there's an independent control that just controls the loco brake. The loco's vacuum brake for parking purposes. And then this is the train brake application valve. Pull that down and that puts the brake on. And you've got an ejector steam control there to put steam into the ejector cones to make the vacuum. And you can push that forward. That operates the big ejector steam jet, so that if you want to release the brakes quickly, you push it forward for a few seconds and then drop it back to the normal running position. The bunker space is pretty massive, and our Garratts will do several days without being refuelled. They get refuelled by the tractor or the JCB, filling them up when they call here at Demas at the end of the platform. The JCB just comes along and drops it in You couldn't really hand coal one of these like the Ffestiniog locos are hand coaled, usually at Portmeadow. Here, this is the reverser. It's a screw reverser, unlike the FR engines. So wind it forwards to be in forward gear, backwards, back gear, and that's the mid position there. So getting the movement from this to each engine unit is a slight conundrum, and we'll look at that next. From the reverser, the movement is passed to this pin, which then can move this rod that runs the length of the boiler cradle either backwards or forwards, and at each end then via this pin it turns this shaft. So this shaft will rotate like that when you move the reversing gear. The shaft goes to the middle to a space that also contains the steam ball joint, where there's a knuckle joint that's doing that, and then you see the rod there that's jumping from the boiler cradle to that joint there that then operates that way shaft. Right, that's forward gear, that's back gear, and that's mid gear again. This then lifts up the fairly conventional valve gear in the normal way. So, but it's obviously arranged so that when the loco's going that way, this engine's in back gear and that engine's in forward gear, much like a fairly. So this is the ejector, and the ejector exhaust pipe, it goes down to the smoke box, exhausts up the chimney, and then that's the steam valve for the ejector. You can see the pipe coming off the manifold, and the small and the large valves are in there and supply steam to the cones via these two pipes here. So that's Gresham and Craven's SSJ, which stands for Separate Solid Jet Ejector. It's used on the BR standard locos and many other locos around the world. So it's good equipment that's well proven and relatively modern in steam loco engineering terms. Side is the exhaust from the rear engine coming forward and then joining up in the blast pipe with the exhaust from the front engine. You see the exhaust pipe is much bigger than the main steam pipes. That's because basically the steam is expanded in the cylinders, so it needs a bigger pipe to get out. If this was as small as the live steam pipes, then the loco would be really throttled. This is a Garratt engine unit. It's relatively small compared to the whole loco, but that is an advantage of the Garratt in that you can relatively easily take an engine unit out from underneath and everything is reasonably accessible to work on. So this unit is was used under 143, but now it's going to be used under the overhauled number 138. So some of the things about the Garratt unit are, first of all, the suspension. So if you have a look down there, you'll see this link that pushes down on the truck spring, and it's also connected to this end of the driving axle spring, and then the other end of this spring connects via this pin to this rocking link here. It connects to the next. So what this mechanism is doing is it's equalising between the axles. So in here is a pivot point. So if more weight comes on this truck axle, say it comes to an uphill, slightly uphill bit of track, it'll push this up, which will pivot this arm and add more weight to this. So what this does is that it tries to compensate or equalise, depending on the proportions of these arms, the weight between the different axles. So it makes it very good for vertical curves in the track. Basically, it keeps the wheels on the track and it stops one axle taking much more load than it's designed to, or similarly a wheel lifting off the track. So that's quite a sophisticated arrangement. It was used more on colonial locomotives rather than British built locos. The same system operates on the front truck. It's anchored there, but at this end of the truck spring you see there's this hook, and then there's an arm that's pivoted under the cylinder, and then that goes onto the front of the leading coupled spring. So there's one fixed position, which is here, which doesn't have a rocking pivot. So the idea of that is that there's one kind of datum position in the equalising gear that isn't available to rock. Otherwise, you could get a situation where the whole engine unit was tipped one way or the other, not level, but still equalised. So anyway, it works very well, and you can see pretty much straight away if there's a broken spring or something is amiss with the gear, because the equalising beams will go to the limit of their travel if, say, there's a broken spring or something like that. In the middle here we have this is the main steam pipe. So that's coming from the smoke box superheater header. It supplies steam down here through this joint here, which is a sliding joint. It's fed off the mechanical lubricator, so the sealing of the sliding joint is finally done by oil into metallic bits and rope packing in that joint. So what that does is that if the engine unit pitches up or down, then this length might change slightly, and even a slight change in length on a solid pipe would probably crush the ball joint or start to fatigue load the pipe. So it needs a sliding joint to be able to deal with that sort of change. And of course, as it gets hot, the pipes will expand. Below is the exhaust pipe from the cylinders at the front going to the ball joint at the back. That doesn't have a sliding joint because the ball joint is looser and it has in it a sliding section as well. That's back there. That's half a ball joint. You can see the female part of the joint, and you can see the springs and studs that pull the other half into it. And as I say, that's right under the pivot, which is this bit here. So all the way to the boiler cradle and the rest of the locomotive is pressing down onto this brass. So the boiler cradle can turn relative to the engine unit like that, and it's trapped by these bronze segments, and then that's nothing to do with it, but this bit at the back, that bit can move backwards and forwards slightly, and what that does is you can take up any wear by turning a bolt just here. You can screw in a wedge that pushes this out from here that way, so it can tighten up on the male pivot part under the boiler cradle. So, and again, this is oil fed from the mechanical lubricator, so it's kept nice and lubricated. Say under, from the main steam pipe, there's a ball joint here. That's where my hand is in the carrier frame, and that again is mechanically lubricated with 2 feeds off the mechanical lubricator, supplying that ball joint, because it's a steel on bronze sliding spherical arrangement, and without the oil it would leak because it's not that perfectly tight, but once it's fed with cylinder oil from the lubricator, then it seals up perfectly, and they tend not to wear very much at all, and give very little trouble, luckily, as particularly the live steam ones. I'll show you where they're located in a bit, but they're very inaccessible, so the fact that they don't give trouble is good. So the Garratts have rocking grates. They're relatively big fireboxes, and a rocking grate is a later development that allows you to break up any clinker, and also to tip the ash into the ash pan more easily. So the grate's made up of segments like this. So this is one that's come out of a Garratt, and it rocks on either end, so it'll twist like that. So the fireman can rock the grate, rock one side at a time, using a bar on the side of the loco, so just rock the grate. And here there are fingers that interlock with this section. This is an end piece, so this is up against the firebox side, the firebox end. So there's a number of rocking grate sections in there. You can see that the gaps are fairly big, and more recently we've been having trouble with more unburnt fuel than we would like dropping into the ash pans and causing fires in the ash pans unless the fireman's very quick to drench the fire. Anyway, unburnt fuel getting into the ash pan obviously isn't good. It means we've been ashing out more with the coal we've got at the moment. So we've changed the design, and we've got a different rocking grate section. So this is the new design, which, as you can see, it has much smaller gaps, although it still has the same sort of airflow area, but it has smaller gaps. So hopefully less unburnt fuel will be falling into the ash pan, so it should give us improved efficiency, and hopefully less ash pan damage caused by firemen having fires in the ash pan. These are the fire bricks that make the brick arch in a garret. So you can see these ones have come out of the moulds, and there are various different types. So in each row there's 3 blocks, and like that, and then there's 3 rows of 3. So we've got these new stainless steel moulds, which, as you can see, this one's been filled with the refractory cement, and it's drying out, and then these bolts will be undone and the mould will come apart, leaving the blocks hopefully ready to be dried. So they'll need to stand for some time drying out, and then have a small warming fire put in the loco once they're in the firebox. Because if you try and warm them up too quickly, they can have a habit of exploding, which is obviously not good. But we hope that once an arch is in the loco, it'll last the whole season. Same with the grate, hopefully last the season, and only come out at the end of the year for a boiler exam. So we've got the new style of grate and this improved arch design in 143 now, and so we'll be trying it for the first time this weekend, hopefully on the passenger train. Right, here's 138. As you can see, it's out of traffic at the moment. We've been using 143, 130 and 87 all this year, but the overhaul of 138 is well underway. So you might ask, why isn't the boiler out and being worked on? Well, we're not going to use this boiler. There's a boiler at Israel Newton's in Cromford that's being, it's almost finished at the moment. It's had an extensive rebuild. It's had a new front barrel section, a new front tube plate, a new throat plate, a new back head, and a complete new inner firebox. So it's mainly a new boiler, but with some reused bits. So that's nearly ready to come to us. So the next phase of this loco's overhaul is to lift out this boiler, put it to one side for a future overhaul, and then overhaul this cradle frame and the front unit, which is still there, as you see. The rear unit we just saw in the loco shed. So at the moment this is just sat on an ambulance bogie just to keep it mobile. So 138 will be coming back into service, but as you can see, there's still a fair bit of work to do. So this is the rather difficult area that we were talking about earlier. So this bit is the ball joint, so you can see I can waggle that about and spin it. So there's a ball on the end of there that's trapped, and it's trapped by a flange that goes on there and is trapped by springs and nuts on these studs. And you can see there's an oil connection in this end of the ball joint, and there's another oil connection at the other end. So similarly, here's the reversing gear. So you can see the arm goes off there, and it's clamped around the shaft that goes out there and is operated by the reverser. So this joint is all on the centre, and this bit here, this is the male part of the pivot. So this bit drops into the bronze female part that's on the top of the engine unit, and then this here is where the water pipe flexible hose attaches to go to the back engine's water tank, and this is where the vacuum hose flexible jumps across as well. So none of this is accessible normally except by this little hole above. This boiler cradle here is nominally number 140 Garratt that came some years ago from Africa with, or about the same time as 138 and 143. We've never actually steamed it, but we have used various components over the years, and it remains a long-term aim to have this one running as well. Anyway, this we're looking inside the smoke box here. You can see up at the top is the superheater header, and you can see all the element tubes looping down into the flues and back again. So there's a lot of superheating. There's 15 flues worth, and still quite a lot of small tubes. And then you can see the two main steam pipes coming from the superheater header down the side of the smoke box to go out respective to the front and back engine units. So unlike a double fairlead, there's only one regulator. It's a conventional boiler, so you apply the steam to both ends of the loco at the same time in the same amount, unlike a double fairlead where you can have individual control of each end. Some people argue that's a disadvantage. I'm not sure that it is really. Maybe in very slippery conditions it might be useful, but generally it doesn't make a lot of difference. These pair of engine units are nominally belonging to 140, although a swap was done a few years ago with a unit for 143. So one of these belongs to 143 and the other one is 140s. But anyway, they both basically now are 140s engine units. So they're stored away in the dry here. So as I say, in time, hopefully we will get them running again.